Welcome everybody, my name is Dario and today we're going to be talking about Milan's Jovanovic, the insane performance boost of CQRS read models, and some misconceptions that are in this video that can lead to some problems in your application. As a bonus, there are going to be two misconceptions debunked on SQL and EF Core. Let's go and see how the video starts and let's talk about it.
What are read models? It's a data model specialized for reading, as the name suggests, and in this video I'm going to show you how to implement read models. In CQRS, which stands for Command Query Responsibility Segregation, it's common to have two types of data models. You have the write model and the read model.
Okay, so here is the first thing that we need to address, and it's the concept that it is not common to have two models in CQRS. It's actually mandatory, otherwise we will not be doing CQRS, we will be doing something different, like for example CQS. I am not a big fan of everything that Martin Fowler publishes, but I'm going to use him as a reference. Here, he states that, where is this? The change that CQRS introduces is to split that conceptual model into separate models for update and display. And it's clear by the definition of the pattern that we need to have different models. Having different models means that it's not common, but it's mandatory. And it could be more than two models. It could be a write model and 3, 4 read models. So it's making sure that there are at least two models on CQRS is the first premise. Now let's see how it's implemented on this video.
The next problem to solve would be, when do we actually create our read model?
We can see in the video that he's using Entity Framework Core and has two DB sets, one for orders and one for order summaries. What I can imagine now is that he is going to be using two different tables for each one of them, so he's going to save them separated. Let's see how they are created.
So let's go to the create order command handler and let's take a look at the handle method. One solution would be to create the read model as soon as we apply some change to the order. For example, we can create the read model here right after we add our order, and we can do something like this. We can say order summaries, and we can add a new entity which is going to be an order summary, and we can specify the order ID value, the customer ID value, and then the total price is going to be 0 because this is a new order without any line items.
Okay, so the first thing that I would say here is that this is a possible way of implementing CQRS. You will be saving at the same time the write model and one read model. Remember that you may have a lot of different read models. And the first question is like, with this approach on a SQL database, it's going to be extremely difficult to add more new read models. Why? Because it's static. When you have to add a new order summaries V2 read model, you will have to pre-calculate or recalculate everything, and that could be a problem. The other thing is that you have to make your CQRS implementation tailored to the needs of your business. Please make sure that when you create an application, you do what is best for solving the problem that you are being tasked for. For example, in one of my previous companies, the core of the business was to write data without failing and in the shortest amount of time possible. That means that if I was going to do what he's doing now, I was probably going to get fired. Because this, in a high throughput system where we were processing a lot of data, writing, we were adding a lot of burden into our storage. So it's usually common that the read models are calculated after the right model is saved, generating what is called eventual consistency. I'm not saying it's the best solution or the only solution, I'm just saying that this solution can cause some problems if you don't do it correctly. Some people in the comments also mention that you will end up having issues if you don't update correctly your model all the time, and that is also a point to address. Let's go and move forward to the bonus of the misconceptions in this video. And for that, we need to move all the way to here, to the query part.
And we want to query the order summary. So if I send this request, we hit the breakpoint inside of the get order summary query handler. So this is going to query the order summaries table by the primary key, which is very fast with a relational database because we are using an index seek operation, which immediately retrieves the row that we want to read.
Okay, that is the other misconception. And I have to make a huge red flag on this. We don't know how the engine that we use is going to implement the plan to execute the query that you're doing. You can try to manipulate this database in order to use an index or not use an index, but at the end it's the engine that is going to decide. I will show you right now how Postgres is not using a seek to search a specific object given an ID. You can see here that there is a countries table that has an ID, a name, and an alpha code. The ID is a unique ID, and then we have an index on this ID. If I ask Postgres to explain me how this query is going to be resolved, you can see that there is a scan on the countries. Basically, this is not doing a seek. Why? Because Postgres realized that the size of the table is too small to do an index seek. So for someone that has been working with databases for so long, please be careful making assumptions that you're gonna get immediate performance boost just because there is a select and a exact match on an ID. As a bonus, for those who are working in .NET, let's see another piece of code.
So if I press continue, we're going to see the response back from our API. One thing that you can do, and that I forgot earlier, was to use a no tracking query. That's very important for read-only queries like this one, because you don't want to be losing performance to change tracking if you're not going to use it.
So he correctly says that it's important in queries like this one. I don't know what he refers with as this one, but I can tell you that the as no tracking is not a good performance boost in every scenario. Sometimes for query, you don't want as no tracking. And that has to do in the way that Entity Framework manages tracking entities that you're bringing into memory. So in this specific case, yes, as no tracking makes sense. But if you're gonna add an include, and obviously that you would probably not do that in a read model, if you're adding an include to another properties, as no tracking probably is not going to be the best performance boost, and actually is going to be detrimental for your application. So to summarize, I would like to share with you this, and is digging into CQRS, we can see that for the models, there has to be read and write, and they must be different. About storing the data, writing and reading can happen on the same store. It can happen on the same table if you're doing SQL, or they can happen on different stores. And let's remember that when you create your application, just think about your domain, tailor your models and the architecture, and make it as simple as the requirement that you have. Do not over-architecture things. Do not apply CQRS for everything. I'm not saying that he does or he's asking you to do it. I'm just saying that after doing this mistake myself, of trying to apply CQRS to things that don't make sense, like a CRUD of a user, of a customer, or of an order. That doesn't make too much sense. Query by index on SQL engines doesn't mean index 6 always, and as node tracking is not always better in terms of performance. If you like this video, please, as everybody says, hit the subscribe, give a like, leave the comments, and happy coding.